Greetings to all. This is Murli Subramaniam. So we are in the unit number one for the subject process planning and cost estimation. So far we discussed a few topics related to process planning, cost estimation and related content like a bill of materials and process planning for parts, process planning for assembly and factors influencing material selection, process selection. We have discussed in our previous lectures. Here and today we are going to discuss about few more topics from unit number one. The first topic we are going to discuss today is routing. So if routing in the sense it has a route sheet and route card. So we are going to see the difference between both of them. Then few topics related to process plan like what are the documents needed for process planning. And with the example we'll wind up this lecture. Okay, so let's begin. So routing, what is meant by routing? It may be defined as the selection of path which each part of product will follow, which being transferred from raw material to final component or finished product. So the selection of path which each part of the product will follow means we have to choose a path where the raw material will be transferred in terms of final component. That is what called routing. Simple, like we are traveling from one place to another place, we choose one particular path, even though it has a n number of ways to go, but we choose one particular path by having various criteria to decide that particular path. Similarly, in industry, manufacturing industry also, we have various path, but we'll be choosing a path where raw materials will be converted into finished component by using various machines, but again with the path will be a beneficial one for the industry. As simple as that. Okay. The routing determines the most advantageous path to be followed from department to department and machine to machine till raw material gets into final shape. Each and every stage in industry, we have to think which way or with which path if we travel will be beneficial. Department to department as well as machine to machine. Department to department in the sense, according to individual product, you will be the individual product will be traveling inside the industry various department, starting with casting department or machining department or surface finishing department or welding department or drilling department or inspection department or painting or polishing like that. Okay, so and also machine to machine, various machine tools start from basic lathe machine to drilling machine, grinding machine, or assembly machine, or injection molding machine, or casting equipments, furnace. So many things are there, right? So department to department or machine to machine, if it travels, the routing will determine most advantageous path, which is good, add value as well as reduce cost for manufacturing, save time, reduce the wastage of. Okay, so many things are involved. So the routing determines most advantageous path, and this path will give us what kind of sequence it should go. That is what sequence of operation to be adopted while being manufactured. So sequence of operation should be best and cheapest to have the lowest cost of the final product. Okay, that is very very important. So this help us. The routing help us to determine the path. That path needs to be most advantageous, and also it will be giving sequence of operation with the best and cheapest and low cost for the final product. Okay, it also follow department to department, machine to machine. So what are the steps involved in routing? Types of work to be done on products or its parts we need to identify. What are the operations required to do the work we need to clearly know that, and sequence of operation, where the work will be done, which machine where the work will be done, the proper classification of the person required and the machine for doing the work, like allocation of human operators or allocation of machineries for the particular product. All is important. How we can able to allocate machine, which machine going to do the work, which operator going to do, which operator in this again it has a consideration. Why? In the sense, operator may be having in various level. Various level. What I mean is the skill for them. Maybe person just can do the operation without any technical skill, just to do the material handling on a pick and place kind of thing, or just to do the drilling operation in the drilling machine alone. Then person who operate in CNC machine, he need a little more skill compared to the person simply doing the drilling machine, right? Similarly, person doing some quality check in other quality check department, they need a better or a different skill set. Okay, so allocation of personnel depends on the task to be done is also very important. So and machinery is going to do also very important, right? So all this depend on what type of work we are going to do, what sequence or what are the operation need to be done, and what sequence and where it is going to be done. So with this, we can able to plan some routing. So this routing provides the industry the basic scheduling, activating the task, and supporting us for monitoring. Okay. Under the routing, we have two techniques way in which we can able to do the routing. One is through route card, another one is through route sheet. The root card is more focused on individual process steps and execution on the shop floor. It is mostly focused on individual process steps, but when you consider the root sheet, it provides a broader overview of the entire production process, focusing on planning, scheduling, and resource allocation. So root sheet and root card. The root sheet is the broader one, biggest one, under which only we have the root card. But root card will go to the shop floor, like focused on individual process. But root sheet will provide us a broader overview, entire production process, and also it focus on planning, scheduling, and resource allocation. So master in the sense root sheet. Under the master, if we have subclasses, then we can go with the root card. So this is the example for root card. The right side shows the example for root card. A root card is a document which is used to manufacturing, which is used in the manufacturing that outlines sequence of operation, under which sequence of operation we need to do for particular product, which move through inside the production process. We have to. This will give us guidelines for the shop floor people or shop floor workers. Shop floor workers will see the sheet. Okay, the task being completed in the previous operation. What we need to do. Okay, if I have done the work in my workstation or in my machine, where I need to send this product to the next stage. To have clear idea, a root card will give sequence of operation for particular product. Okay, for example, in the right side you can able to see a root card where it gives sequence of operations. First it should be done, after that what, like that first we need to do the parting, maybe assume like parting in the sense separating from the lengthy cylindrical rod in the lathe machine. So you have a lengthy rod of 1 meter or 2 meter. So if you want to make it like a 15 centimeter, 15 centimeter, 15 centimeter pieces. So parting will be maybe in the first 15 centimeter, maybe the process being done by previous machine. Then parting, if you are doing means that will be separated. So that parting, if we done, we need to done face grinding and the face grinding. So face grinding also needs to be done rough one, rough two, and final facing face grinding we need to do. Like a rough one, rough two, maybe the grinding may be removal of material. Maybe the rough one, rough two, in terms of how much mm it is going to remove. Then final rough grinding. Then outside diameter grinding, like a cylindrical grinding machine, you can assume like a external grinding we can able to do. Again, there it has a rough one, rough two, and finally finish. So directly we can't do the finishing operation. Stage by stage only we can able to do. So that's what it is. That sequence of operation also listed in the root card. So once it is done the cylindrical grinding, then it goes to the turning process where you do the boring operation and radial grooving or grooves or chamfering. After that, it will go to the magnetical particle checking, final inspection, or any missing component is there. Then they do the visual inspection, final oiling, packing in the supplied parts. So these are all the sequence of it depends on one product to another product, but each and every sequence of operation needs to be listed in the root card. This is what the root card, which will give us a guide for the shop floor workers. Okay, because randomly they see one product on the shop floor, on the dais or in the bin or in the cart is there. So along with the root card, it should travel. Okay, so once they take the root card and see, okay, this process being completed, now they go to the next like that. So when the work being done, the date are given and also under which shift, day shift. If you have a two shift, day shift or evening shift, it will be given which machine it has been done, what is the quality, it's okay or rejected, who done that operation, what is his ID, ID number, every information will be given in the root card, particularly for the one product dedicated dedicated for the particular product. Okay. However, in terms of root sheet, as I said, it is a detailed document, broader sense only we have to give. It will give overview of sequence of operations for the entire product. Okay, it gives us all the information related to the whole product are considered like an assembly. So maybe one particular one part alone, then it may go to root card, but collection of root card, put it together and we can able to make the root sheet. It's an overall view. It will be given the outlines. Okay. In manufacturing, a root sheet is a detailed document that outlines the sequence of operations or processes needed to produce a particular product. It's not the part; it's a product. It act as a guide for the manufacturing process, providing essential information on each step to ensure that production runs smoothly, efficiently. So what are the key components will be there in the root sheet? All the information related to the product. Product information, like product information is basically what? Product ID, part number, part description, what quantity will be there. Routing information, like route cards will be there, operation sequences, work center tools, which equipments being used for that. Then time estimates, what is the setup time, what is the ideal time, or what is the run time, what is the inspection time, what is the completion time, and what kind of materials, what are the resources available. Resources, as I said, like is labor. What level of labor, skilled labors, uh, whether needed or any special tools needed for the inspection or material handling, how we are going to do the quality inspection, wherever we are going to do the quality inspection, whether each and every workstation after completing the particular manufacturing process or machining process, we need to do the quality inspection or at the end. So like that, we need to have a checkpoint. It depends on the what kind of product design we have. Okay, so it is very, very important. So it should be decided in the beginning itself. Then progress tracking, where workers do sign off or stamp after completing each. So each and every time, maybe in the previous thing, it is inspected by someone or approved by someone like that. Email signatory location is there. So it is like a progress tracking. Okay, one after another, they will be checking and say that by seeing that particular sheet itself, they'll understand. Okay, this kind of process being completed as of now, like that they can able to track. So or some other special instruction needed, like a handling instruction or maintenance schedule. Maintenance schedule, as I said, it is overall plant maintenance schedule or environmental condition, how we are going to maintain, how many number of sorry, what kind of temperature needs to be maintained, humidity needs to be maintained, ventilated, kind of information or cost information. Every information will be there in the root sheet. So comparing with the root sheet is the broader one. It has all the information related to the particular product, including all the sequence of operation processes involved. So this is the example of root sheet. Maybe we discussed about this route sheet long back, for a simple example, like a selection of process kind of thing. So here, so route sheet it is giving like what are the operation and what machine, which machine going to be used, what kind of tool going to be used, under which department, like what is the time required, how much time it's required, all the sequence of operation. So overview will be given. Okay, overview will be given in this route sheet. So this is another example for the route sheet. It also given what kind of operation, sequence of operations, machines, tooling, setup time, cycling time. Okay, so who is the planner? So like that, detailed information will be there under the route sheet. So this is the main difference between route sheet and route card. So in the left, it is given what purpose, what is the scope, what is the content, what is the usage, and what is the focus. So with respect to the purpose, route sheet is used for planning, scheduling, and resource allocation because it's a broader sense. That's why that is the purpose of route sheet. But in terms of route card, it's it's acting or working like it's for useful for execution, tracking, and instruction for the operators or shop floor workers. So comparing with the route sheet in terms of purpose, route card is useful for execution, tracking, and giving instruction to the shop floor workers. But in terms of route sheet, the purpose is for planning, scheduling, and resource allocation in overall view, broader perspective. And for the scope, it is route sheet is the high level, and covers entire production process. But in terms of route card, it's focused on individual operations alone. In terms of content, it gives operation, work center, labor, time, and cost. But in terms of route sheet, it gives the step-by-step process, tools, machines, operators needed for the particular product or part. Usage used by the planners and supervisor. Route sheet is used by the planners and supervisor. But route card, as I said, it is used by the shop floor workers and operator. What is the focus? Strategy and process design is the focus for the route sheet. But in terms of route card, operational execution, that is what the first point. Route card is used for operational execution and tracking. In short, what is the difference between route sheet and route card? Route sheets are used to plan and organize the entire production process, while route card are used to guide and track the execution of individual tasks in real time on the shop floor. So I hope you guys are clear between route sheet and route card. Now let's move on to the next topic. What are the set of documents required for process planning? So far, we discussed many topics. So from the topic itself, we could understand that these are all the information we need to have in order to do some process planning. Assume like this table, route sheet. This is also route sheet. See what are the information available in this route sheet. So name like what are the machines, what are the department. Different departments are there: lathe department, drill department, milling department, and machines L45, D09, M32 means M means milling, and 32 is the number of the name label of the machine maybe, and L is the lathe. Then tooling, each tool they have some number, and which department, how much time, what is the name of the component, what is the size of the component, what is the material classification, what is the part number, who is checking. Okay, so like many information is there. Similarly here also, how much setup time, what is the cycle time is needed for that, and tolerancing information also there in this. Okay, so these are all the basic details available in the root sheet. So this information will be there as a document. Yes, of course, it will be there. And again, previously we discussed about material selection, factors influencing for material selection, process selection, where we also discussed some of the information needed. So those information definitely will be there as a documents. So those documents only consider as a set of documents required for process planning. So set of documents required for process planning is product design and engineer drawing pertaining to all the components of the product. So we discussed about the bill of material, engineering bill of material, where we discussed about the part drawing. So part drawing, engineer drawing is very, very important. So that includes components drawing, specification and bill of material that defines how many of the each component go into the production or into the product. So how many of the product going inside? If you have a big assembly, how many number of product are there? How many number of sub assemblies are there? How many individual parts are there? What is the size of them? What is the specification of them? And how many numbers are there? What is the drawing of that particular individual part? Every information is needed. So that is one set of document we need. And machining and machinability data book, like a table of cutting speeds, depth of cut, feeds for the different process and for different work material. So simply we can't able to select cutting speed or depth of cut or feed rate for our own. We should follow certain guidelines. It is already framed and it is being documented as a data handbook for machining and machinability. Assuming like we might have done some operation in our machine shop for rough turning, we have given like a zero point 0.5 mm depth of cut with the spindle's rotation speed of 400 or 450 rpm kind of thing. It depends on what kind of material are we using. Maybe we used mild steel. For the mild steel, we used 400 rpm of rotation speed with the zero point 0.5 depth of cut. If we give for the mild steel 3 mm of depth of cut with the HSS tool, what will happen? The tool failure might happen, right? So there is a guidelines followed. Like it is, it's not like someone like already people might have worked for different material and they understand the failure behaviors and they documented that up to what limit, what range we can able to, or maximum limit we can able to. With that understanding, they prepare the standard machinability data book for different materials. So people are nowadays working with the different materials like composite materials and that. So that's why people working more on optimizing the cutting parameters or optimizing the machining parameters. Like that we could be able to see a number of research being happening. Why? In the sense they are not working for mild steel material. Why? Because it has been done and documented properly in the long back by someone that did that research. Similarly, people are working on for various composition of material like composite material. They want to find using optimal cutting speed or depth of cut or feed rate for the particular process, like a turning process or in turning, rough turning process, how much, or finishing process, how much, or polishing means how much, or like a cylindrical grinding means how much. Like that, they are working and they will be publishing that in the research articles, then can be used as a standardized, it will be documented as a standardized data handbook. So those information, like one data set or document needed. Then catalogs of various cutting tools. If we see cutting tools, we have n number of tools and n number of inserts. Depends on the material we want to and about what kind of depth of cut are we going to do, whether are we going to do the rough or finishing operation. Depends on that. We have to use select the cutting tools and tool inserts we need to choose. But it has a catalog, so that document we need. Then specification of various machine tools available in the shop or catalogs of the machine tools in the shop. Like what is the capacity, what is the range of the machine, what is the spindle size, what is the stable size. Okay, because according to that, the specification or dimension of the component and spindle size and table sizes are correlated. How? In the sense, if you have a bigger in size of component, but your table size is smaller, then you can't able to mount that on the table. Similarly, if a cylindrical component, this is the diameter of the workpiece is bigger than the range which can accommodated in the chuck, three-jar chuck or four-jar chuck, then you can't able to plan the work. Okay, so you should have a data of machine tools and what capacity it can, the range it can work. Those information needed, right? That also will be there as a document. And the size of standard materials commercially available in the market. So what are the material available in the market? We should have a basic information, because people anyhow going to work on those kind of materials only. So according to that, we have to prepare our own facilities in our industry, right? So those information we should have. Then each machine, if we are working on the machine, each machine need to have some cost. For example, if we are working on one what to say, shaping machine. So if the shaping machine one worked for 1 hour, how much cost? Because we need to have that kind of calculation. The people already made that. Because simply we can't able to make it like 100 rupees for 1 hour like that. No, because return on investment on the particular machine is important. So with that, they might have planned some our values or cost for that particular in terms of our basis. So that data is needed. Then design data handbook. And when we are working on one component with functional requirement like moving components, in the sense we need to consider about the limits, fits, and tolerances. And if we need to have a limits, fits, and it also has a table or predefined standard data books are there. Surface finish also needed because it depends on the surface one finish requirement. We need to choose the proper machining process. Those information also needed. So these are the basic information. Along with that, so when we are calculating some cost, we need to consider about the allowances because people can't able to work like a robot like 8 hours or continuously. So that personal allowance, how much time we can able to give allowance for the personal allowance, how much time means like whether it's at 2%, 3% of your overall shift, or fatigue, how much percentage with respect to the standard time. It should be defined by the company, will be there as a document. So by keeping all those informations and documents, we can one can able to prepare a process planning. So this is the rough process plan, as I said, what kind of material, which machine, how much time needed, kind of thing. This is a detailed process planning. The operation description will be there, which workstation, what kind of setup they will be giving. Attach number one for illustration, how to attach the given clear map, like where we can able to mount or how. Maybe there will be a jigs and fixture will be there. So we have to on the fixture properly because the work continuously we are like mass production we are doing. If we have a like machine wise where if we are keeping our component like holding for holding, we need to tighten the screws and all, it takes process. So in that case people go with the fixtures is a kind of template which holds the workpiece, and easily we can able to mount on the table, then we can do the machining process. So this those kind of information also will be there separate document. So they are referring like a refer attachment number one, attachment number two kind of thing, and which tool, which how much time needed kind of thing. This is the detailed process plan. Okay. Then observation sheet for time study. Each time, each machines, how much time needed. Clearly, it is documented here. Pick up a job from particular bin and tighten the drill. How much time required? Drilling three holes, unclapping the job from that machine. Then remove from jig and place it on the particular bin. So each all will be giving operation sheet, like each operation how much time needed, it will be hanged in between in each and every machine. So this is operation for drilling process. Example, one of the example, maybe for milling machine the component is going to milling machine. In milling machine also you need to directly you can't able to put it in the machine. The component or workpiece will be there in the cart. So you have to take it, how much time required to take it, and how much time to place it over the work holding device in particular machine. Then how much time required to fix it or tighten. Then how much time to do the process. Then you need to stop that machine. Then you need to unscrew that chuck. Then remove that. Again, put it on the bin for the next machine to continue the process thing. So each and everything. Again, you see, first task, the second component, third component, fourth component, 10th component, how much time it is taken. And then finally they given like an average. The pickup job from bin took 0.057 minutes. There is a variation because the It is not a robot pick and place. If a robot pick and place means there won't be much variation. But it's like done by human operator in the sense there definitely some variation will be there because they have allowances, critical allowances, personal allowances will be there, and not everybody can able to do the task in same way. So that's why the variation even between operator you can't able to there will be a difference will be there, or within the operator also we can able to assume like only one operator doing the task. Even within the operator we will be able to see the different timing for that particular operation. Okay, so this is operation chart operation chart or operation sheet will be useful for tracking that, and sometime with this information the supervisor will check that, oh, why this much time required, why this much delay is happening. Okay, for example, 0 point tightening a drill 0.13, 0.12, 0.10, 0.10, 0.18. So what is that star value? 0.18, 0.19. This is indicates extreme value, not considered in the calculation of average. Means they are not considering that to take, but this data will be available. Then the supervisor will check what went wrong for making that tightening of the drill. So this is every activity are documented. That is what observation sheet. So here one of the example I'm giving. Yeah, part drawing is shown in figure. Gear shaft. This is the gear shaft for water pump. What are the process planning activity needs to be done? So this is the simple one. With this, we can able to plan what are the sequence. I'm not going to show anything now. Just to think what are the things available here is length of the component. What is the shape of the component? Cylindrical component. It's a cylindrical component because you have a center axis, and you should have think about the because it's a gear shaft it is given. Length is there. And also you have uh, one, two, three cylinders. Both three, not all the three cylinders are in equal diameter. There's a variation in the diameter, and also at the corner you can able to see some chamfering, and also in this corner you can able to see the chamfering. Then here you can able to see kind of a groove. There is a reference kind of something called A, B. It's all representing the datum plane or referencing, and each and every dimension they are given with some a tolerance value like a plus or minus value. In terms of chamfering, they have given plus or minus 1 degree. The chamfering can needs to be done with 45 degree. Here also 45 degree, and here the chamfer for that the horizontal distance is 1.5, and here the diameter is 7.55 to 7.65. Here the diameter given, and also overall diameter, and what material is given. 25 diameter SAE 1030 cold drawn steel is given as your raw material. The final component is not 25, it is lesser. So original component is 25 diameter cold drawn steel. Clearly they given what is the size of the raw material, what process the material came from. Okay, then tolerance value is given plus or minus 0.05 unless otherwise specified. If there is a tolerance value not given, it should we have to take like a plus or minus 0.05, and if it is given we have to take, okay, we have to consider that like a plus or minus 1 degree. So all the dimensions may be in centimeter or something else, but here clearly given all the dimensions are in millimeter. How many number of parts are needed? 5 numbers is needed for similar like this. So this is an classical example where we need to prepare a process planning activity. So where to start? I hope you know what are the machining sequences we need to do. We can't do we can't do directly every process, like we can't do like chamfering. First we need to reduce, right? Because raw material is 25 directly we can't do the chamfering. Why in the sense? Because instead of 25, the final is needed with between 22.80 or 22.90 only. We need to do some turning operation, right? So that kind of sequence of operation is so I'll be explaining in the next slide about this. So do remember about the drawing. So study and read the drawing so that part features are identified. The important features are here. One. Three concentric cylinders is there. Yes, What are the three concentric? One, two, three. Three cylinders are there. There is one chamfer, 45-degree cross 3 mm, 45 cross 3 mm is given because 45 cross 3 mm, this one, and 45 cross 1.5 mm at the ends of the shaft. Not both the chamfer is equal. One is with 45 degree, angle is 45 only, but chamfer size is the 3 and 1.5. Then the dimensional tolerance is given plus or minus 0.05. Angular tolerance is given like a plus or minus 1 degree. And material also needed, as I said, ACE 1030 made up of gold drawn steel. So they need how many number of pieces? 5 pieces required. So the most feasible process is machining on a standard central. So for this, no need to go for like a centralized like CNC machines or something. If we go with mass production, we have to go for CNC machine. But here is the 5 pieces only needed. So center lathe is sufficient for that. The parts can be machined from 25 because original diameter is 25 mm. It can be machined from 25 mm start. Then one lathe operator is sufficient to complete the order, this particular order. What could be the next step? As I said, we should have a basic fundamental in machining process like cylindrical component. We need to do the facing, we need to do the drilling, we need to do the cutting or part of because 5 pieces. Okay, 5 pieces. Maybe they may be having a 25 mm diameter of rod, lengthy rod. So we need to cut down according to the need. Then turning operation, chamfering operation we need to, and finishing operation we need to do. In addition, the process planner must estimate the time for each of these operations, like how much setup time needed. Directly it won't go inside the chuck, right? We need to take that raw material and put it inside the chuck and lock the chuck and also cut setup time, how much cutting time required, and what cutting tools needed, what are all the jigs, what are all the fixtures we need, and what are all the gauges going to be used, and what is the machining parameters like cutting speed, speed rate, depth of cut are we going to use. We should have that. The process planners must know this information. So completing the process planning sheet, the operation listed are sequenced in numerical order. Sequence of operation like where to start means that should be given like a first one, second, third, fourth. So numerical order and are listed in the process sheet along with other necessary information. So this is the example. That particular example we can able to use. So first we need to do the phasing. Phase end. Which machine are we going to use? Central lathe only we are going to use. As I said, everything being done in the central lathe. So machines for all the processes central lathe only. But cutting tool differ because we need to do the chamfering, we need to do the facing, we need to do the turning. Turning also simple turning or smooth finish turning, and we need to do the parting also, right? So cutting tool and how much cutting speed in terms of RPM, how much feed are we going to give, whether the feed automatic or manual feed, how much depth of cut, locating points on the drawing where it is located, the face end it is located where, and what kind of fixers they are going to remark. Use three check the universal check. They are going to use three check in the sense you need to adjust each and every jar. So it takes time. So the setup time may be needed. So all should be documented. Then we use a central drill. Again, the drill bit will be kept under the tailstock end, and we can able to do that. Okay, cut off removal of sharp edges, like all the sequence operate like sequence like a list needs to be given. Then each and every drawing has a drawing, technical drawing. It is that drawing, this drawing will be there. So this drawing has its own drawing number. That is what given like a 76-10 GM, and part name is gear shaft. What is the material, SAE, and who approved and when they approved, how much stock number is there, what is the specification number. Every information is given in this process plan. So this is the example for the process planning for that particular component. So with this, I'm going to wind this particular lecture. In the coming lecture, we are going to discuss about what are the process planning, traditional process planning will be there, or computer aided process planning are there. So we are going to discuss that in the coming lecture. Okay, I'm going to close this lecture. Thank you.